Hello and welcome to Chapter 9, Thermochemistry. If you're going through the textbook also, please be aware that we are covering 9.1, but we're only covering 9.2 until example 9.4, and after that point you're going to skip the rest of that section of the chapter. Then we're going to do 9.3, and notice that we are skipping 9.4. So 9.1. This whole section is all about energy. So energy is the ability to do work or supply heat. The formula for work is negative P for pressure times change of volume. The formula for heat is Q. And when you add those two terms together, and I know it's negative, but you're still adding, you're going to get your total internal energy, and the symbol we use for that is a U. Now, we aren't going to be doing very much with that equation, but this is in the chapter, and you should be aware of it. You should know the units for energy. You should know the units for energy. It's a joule. Be careful because sometimes charts will be in kilojoules. Sometimes they'll be in calories with a big C. That's a food calorie. To save space, they'll use both of those units, or sometimes they'll use a little calorie, and they are not the same. Isn't that frustrating? So we use little c when we're doing chemistry most of the time, unless, again, we're talking about food chemistry. And this is going to remind you of grade school a little bit. You remember the phrase potential energy and kinetic energy? It's the energy an object has because of its relative position, composition, or conduction. So this is, like on the waterfall, the top of a waterfall, a compressed spring, a bow drawn with an arrow. It's like the energy, you can almost tell it's about to happen, but it hasn't happened yet. There's a little Newton comment here too. Gravitational potential energy, it increases with increasing height and increasing mass. So what this means, if you're dropping a bouncy ball off of the coffee table, it has less energy than if you're dropping a bowling ball off of the top of a waterfall. In contrast, we have kinetic energy, and that's the energy an object possesses because of its motion. So again, you can see the motion. The water is actually falling. You have the bouncing spring. You have the arrow flying. So we're going to go and look at this simulation, and when we get back, we're going to review the different forms of energy and how